Hello, today we're going to be talking about air masses and fronts and the relationship between them that causes weather. To start out with, we're going to take a look at the difference between warm air masses and cold air masses. So remember, an air mass is a body of air, a body of gas, that has common characteristics. So a warm air mass is going to be warmer than the surrounding air. Okay, that's what it has in common. It's warmer than the surrounding air. Because it's warmer, it's also going to be less dense than the surrounding air. And because it's less dense, it's going to actually rise and float above the surrounding air. The particles in warm air have lower pressure than the particles in surrounding air. They have more energy, so they're more excited, they're moving faster, and that causes them to be spread further apart, which makes them less dense. Warm air can also hold more water vapor. Water is more likely to be a gas when the air is warm, so it can hold more water vapor than cold air. It does not condense. Okay. In contrast, let's take a look at a cold air mass. So a cold air mass is cooler than the surrounding air. It's also going to be more dense than the surrounding air, and because it's more dense, it's going to sink quickly. Colder air, colder gas particles, do not have as much energy, so they're still a gas, so they're still moving pretty quickly, but they don't have the same amount of energy as warm air, so they're going to be closer together, they're not going to spread apart as far, and that's what makes them more dense than the surrounding air. Because of condensation, cold gases can hold less water vapor than warm. So they hold less water vapor because the water condenses more quickly when the temperature is low. So that brings us to a cold front. So a cold front is an event in weather that occurs when a cold air mass quickly overtakes a warm air mass. The cold fronts move very quickly because the air is very dense. Some of the weather associated with a cold front is strong, fast winds. They often occur around a low pressure system, which is sometimes called a cyclone. They bring cumulonimbus clouds, which are those big fluffy clouds that sometimes get darker and look like thunderstorm clouds, and they bring cooler temperatures. The symbol on a weather map for a cold front is a blue line with triangles, and the triangles point in the direction that the front is moving. Okay, so for example, in the illustration here, we have a cold air mass overtaking a warm air mass. As it moves into the warm air mass, the warm air is going to rise here and cool when it comes in contact with the cooler air. That cooling causes condensation, which creates these clouds, and eventually the clouds will become too heavy with water vapor and precipitation will fall. You see the symbol here for a cold front, and it's moving this direction, the way that the triangles are pointing. Air in this particular picture, or wind, would occur in two directions. You would have quick, cool wind blowing this way with the cool air. You would also have lighter, warmer wind blowing this way as the warm air rises, since it's less dense. All right, let's take a look at warm fronts. Okay. Warm fronts are the opposite of cold fronts. So warm fronts occur when a warm air mass overtakes a cold air mass. Warm fronts move slower because the air is less dense in a warm front. Some of the associated weather with warm fronts. Usually at first, the weather is going to be clear and fair. Rain and storms may follow behind a warm front. Warm fronts often have stratus clouds or cirrus clouds, which are wispy-looking clouds that are high in the sky. And often they occur around a high pressure system. A high pressure system is sometimes also called an anticyclone. You can see in the illustration we have a warm air mass coming into contact with a cold air mass, but the warm air mass this time is going to overtake the cold air mass. As the warm air mass comes in contact with the cold air mass, at first there's just a tiny bit of condensation, which results in those stratus clouds. Over time, it's going to condense more and more. So behind this warm air mass, you might actually have a storm or some precipitation. And notice here the warm air mass is winning. It's taking over the cooler air mass. Wind in this example is going to move in the direction of the warm air mass, so it's going to move up like so, okay, and to the right. Notice the front is traveling to the right, and that is why these half circles are pointing toward the right. The symbol for a warm air mass on a weather map is a red line with half circles, and the half circles point in the direction that the front is moving. All right, next up, let's talk about stationary fronts. So stationary fronts occur when a warm front and a cold front meet, but neither takes over, okay? You can see the symbol for a stationary front on a weather map is the combination. It looks just like a combination of a warm front and a cold front. So you have red half circles pointing in one direction, whichever direction the warm front is moving, and you have blue triangles pointing the other direction, the direction the cold front is moving, okay? Weather associated with a stationary front. You're going to have long periods of precipitation. If you are stationary, that means you're not moving, you're still, okay? Stationary fronts tend to sit still for a long time, so you have a long period of precipitation. They often occur around a low pressure system, and the wind is going to blow parallel to the front in this particular phenomenon. So in our illustration, you have a cold air mass moving one direction, you have a warm air mass moving the other direction. As they meet, neither air mass wins, okay? They just sit still, neither overtakes the other, and you're going to have a long period of precipitation here. Condensation is going to occur along this front as the warm air comes in contact with the cold air, and that will result in precipitation. You see each front is moving in the direction where the half circles or the triangles are pointing, and the wind here is going to blow parallel to this front. So instead of blowing this way against the front, it's going to blow parallel to the front. Last but not least, let's take a look at the occluded front. An occluded front occurs when two cold air masses take over one warm air mass, pushing it up in between them. It usually forms at a low pressure system. So the weather associated with an occluded front is extreme weather. You're going to often have a lot of precipitation. You might have storms like thunderstorms or hailstorms. You'll have cumulonimbus and nimbostratus clouds, and you'll also have cyclones. This is the beginning step in the life of a cyclone. Okay. Look at the picture here because this shows how occluded fronts form. You have a cold air mass with a cold front forming, traveling one direction. In front of that, you have a warm air mass with a warm front traveling in one direction. And in front of that, you have another cold air masses. So see, there's two cold air masses with the warm air mass in between them. Okay? As these form around a low pressure system, they're going to start to spiral in a counterclockwise direction. Okay? If we're in the northern hemisphere. In the southern hemisphere, it would spiral in the opposite direction. Okay? Now remember, cold fronts move very quickly because the air is very dense. So what happens is this cold air mass is moving much more quickly than this warm front is. And so as the cold front moves quickly, eventually it catches up to the warm front. And you can see that starts to happen here. The result is an occluded front. Okay? The symbol on a weather map for an occluded front is this purple line with alternating half circles and triangles pointing in the same direction. So if they're going in the same direction, that's an occluded front. If they're moving in different directions, it would be a stationary front. Okay? As this cold front catches up with the warm front, this whole system begins to spin in a counterclockwise direction. The air is going to rush into this low pressure system because this is less dense than the surrounding air, and as it rushes in, you're going to have the beginning of a cyclone. This concludes our talk about air masses and fronts. Thank you for watching.